using u substitution to work with log and exponential functions. Example 1, integration of x cubed divided by x to the fourth minus 1 dx. Now we're going to use u substitution. We're going to let u equal to the denominator here, u equal to x to the fourth minus 1, du dx equal to 4x cubed, and when we do cross multiply, du equal to 4x cubed dx. Like what we learned before, if you look at its function here, we need a 4x cubed dx. Well, it's missing a 4, so we're going to put a 4 here, and then we're going to have 1/4 outside to balance it out. So now our function, we can do a u substitution. It's 1/4 over 1/4 integrate 1 over u du. Now recall well, we want to take the integration of 1 over u, but what's the derivative? It will give you 1 over u. If we recall that, it's ln of absolute value of u plus c. And once we have that, we just have to substitute u back, x to the fourth power minus 1 plus c. Let's try another one. This one, example 2, is integration of sine x over cosine x plus 1. Well, we're going to do the same thing. We're going to let u equal to cosine x plus 1, and the derivative of cosine x plus 1 is negative sine x. So du equal to negative sine x dx. We look at original question. We have sine x dx. We just need a negative sign. So we're going to add a negative here and a negative outside. So that's what we have here. We're adding a negative to the numerator and a negative outside. So what's inside now? That negative sine dx become du, and then the bottom cosine x plus 1 equal to u. So it's, once again, it's 1 over u. And we know 1 over u, when we take the integration of 1 over u, is ln of absolute value of u plus c. Substitute u back in, so it's negative ln of absolute value cosine x plus 1 plus c. Now let's look at some exponentials. Example 3. The integral of e to the 2x minus 5 dx. If we let u equal to the exponent here, u equal to 2x minus 5, du equal to 2 dx. We have the dx, we're missing the 2, so we're going to add the 2 inside the integral and then put 1/2 outside. So 1/2 and 2 cancel each other out, so we're not changing the value. So 1/2 integration of e to the u du. Now, we know e to the u, the integration of it is going to be e to the u. So it's going to be 1/2 e to the u plus c, and once we're done, we plug in u as 2x minus 5, then we'll find our final answer. Let's look at this one, same thing. If we have the integration of x, excuse me. So we have an integration of x times e to the 3x squared dx. We're going to let u equal to 3x squared, and the du dx will be 6x. So du equal to 6x dx. If we look at our original question, we have x and dx, we just need a 6. So if we add a 6 in here, we need a 1/6 outside. So now we have 1/6 to the integration of e to the u du. Just like before, e to the u, we just become e to the u when we do integration. So 1/6 e to the u plus c, and then u is 3x squared. We plug it back in, we have our final answer. Example 5. Integration of 5 to the 2x dx. Now we're going to let u equal to 2x, so du dx equal to 2, so du equal to 2 dx. So again, we have the dx, we need a 2. So we add a 2 here, we need a 1/2 outside. So it's 1/2, so we're going to rechange this using u substitution, change this whole equation to 1/2 5 to the u du. Now, if we still recall from derivatives, what derivative would give you 5 to the u? So if we go backwards, the integration is 5 to the u over ln of 5 plus c. That's the integration right here. That's integration of 5u. Then once we have that, we're pretty much done. We just need to plug in 2x in for the u, and then just simplify this. So 1 times 5u is just 2x, and the bottom is 2 ln of 5 plus c. All right, this is last but not least, this last example here. We have the integration of sine of pi x times e to the cosine pi x dx. If you let u equal to cosine pi x, usually it's a good idea to let the exponent equal to the u. So du dx equal to negative sine pi x times pi. Remember this, when we do the derivative, you need a chain rule, right? Okay, so we need this extra pi here. So we're missing a couple of things. Okay, so du is going to be negative pi sine pi x times dx. So we have sine pi x dx, but we're missing the negative pi. So if you add a negative pi to the equation, we need negative 1 over pi outside. So we now can rewrite the equation as negative 1 over pi integration of e to the u du. Then we know e to the u is just e to the u, which is fine. Then when we're done with it, we just substitute cosine pi x back into u. So the final answer is negative 1 over pi e cosine pi x plus c.